The second form of loop is also easy. You have to go from initial point to a final point. How do you do? A for loop. This is the answer. Check these examples. And I'm sure you will be agree with me. This is very easy. Of course it's very easy. Okay? Let's see this example. The objective. Very easy. Read two numbers and show all numbers between the smallest and the largest. So, semantic analysis. Two numbers. Show. What does show means in computer programming world? Numbers between the smaller and the largest. Okay? So the semantic analysis, two numbers are two values. Show is put data in the display of your computer, of course. And between smallest and the largest, the smallest and the largest, this is a range. This is a range of numbers where the begin is the smallest number and the end is the largest number. Okay, if you understand the semantic analysis, you really understand the objective. Remember that. If you can write a semantic analysis, you can say, hey, I understand this objective. IPO analysis. Input, process, output. So, the input. First, read two numbers. So you need to read two numbers. Number 1 and number 2. These are the name of these variables. Process. Second step. We are in the loop form. So you write for aus is a variable. Begin in N1, 2, and 2. Step 1. Step 1 means you are going from N1 to N2 one by one. Okay? Then you write here the content of aus. And this is the end of the for. Probably you say, and where is the increment of aus? It is automatic. Automatically, in the loop for, the variable increase its content. The step 1 means that you are going to increase in 1 each time you increase the content of aus in this example. So the output is all numbers between N1 and N2. Okay. Now let's see the call test. Remember, a memory and display. In RAM memory, variables N1, N2, and aus. Step number 1. read N1, N2. You read two numbers. Suppose you read 4 and 7. Okay? So number 4 will be stored in N1 and number 7 will be stored in N2. Step number 2. For aus is equal from N1. So aus stores number 4. 2 and 2. And 2 is 7. Write aus. Write here the content of aus. And 4 means you're going to the 4 instruction. So step 1 means 4 plus 1 is 5. 5 is still less than 7. So write the content of aus. That means 5. Then step 1 means 5 plus 1 is 6. Now write the content of aus. It means 6. Now step 1. 6 plus 1 is 7. Write aus. So write aus. And remember, the 4 instruction says 4 aus equal N1, 2, and 2. Step 1. So 7 is the value of N2. Then that means we finish the program. Did you reach the objective? Yes, of course, you reached the objective. Now let's see second statement. Objective. The objective is read the numbers and add the numbers between them. Okay? So in the semantic analysis, you have to define what is read in the computer programming world. What are two numbers? And what does mean add the numbers between them? This part with an example. Okay? Let's see, read. It means receive the data using the keyboard from the user of the computer. Two numbers means two values. And add the numbers between them means if the numbers are 4 and 6, the result is add 4 plus 5 plus 6. And that means 15. Okay? Remember, if you can write a semantic analysis, you really understand the objective. Now let's see input, process, and output. Input. First step. Read two numbers. So you only read N1 and 2. The same numbers of the variables. It doesn't matter. Process. Second. Remember, we are going to use the loop for. So we write for aux, another variable, begins in N1, 2, and 2 with a step of 1. But we are going to use another variable. Result begins in O. Remember, you are going to add the numbers between N1 and N2. So you need to write result is equal result plus aus. Okay? And then N4. And what is the output? The output is the result of adding all the numbers from N1 to N2. And this is the output analysis. Very easy, you know. Now let's see the call test. Remember, RAM memory, and then display, right? In the RAM memory, you write the variables N1, N2, result, and aus. Okay. Step number 1, read N1 and 2. Suppose you receive number 4 and number 6. That means 4 will be stored here and 6 will be stored in N2. Result is equal to O, so result is equal to O. Then for aus. Aus begin in N1, that means 4. 2 and 2. So aus is going until 6 with step 1. Result is equal to result plus aus. So result is equal. Result, that means O plus aus, that means 4. O plus 4 is 4. Then N4, step number 1, that means 4 plus 1, 5. Now result is equal to result plus aus. Result is equal to result 4 plus aus 5. That means 9. And 4. We go to the for instruction. Step 1 means 5 plus 1 is 6. Result is equal to result plus aus. That means 9 plus 6 is 15. And 4. And aus is in the top, because the top is the content of variable N2. So output, step number 3, is the result of adding all the numbers from N1 to N2. That means write result. So the result is 15. Look, you receive two numbers, 4 and 6, and this is the result of adding 4 plus 5 plus 6. These are the numbers between 4 and 6, including 4 and 6, of course. Do you reach the objective? Yes, of course, you reach the objective.